Shadows, the most powerful and most overlooked thing in either photo manipulation or any form of art. The topic of shadow is often overshadowed by lighting because we think it's cool. But in this lesson, I will show you how cool shadows are and how fun it is to draw them. We tend to avoid shadows because it darkens things and we want our image to be brighter. But the truth is otherwise. Shadows are very useful and they help us determine the shape of an object. I'll now show you a quick example of how powerful a shadow is, or more precisely a contact shadow. We are in Photoshop here. Now I'll take this random background and drop it here. Now I'll take this little cat here and drop it here. As you can see, the scale is entirely off. Cats are not of this size when you see them on the road. The brightness value on both the subject and the background is different. The coloring is different. The lighting is different. In the background, the light is coming from behind to all the sides, while on the subject the light is only coming from this direction. So as you can see, everything is completely off here. From a photo manipulation point of view, this is not very good asset selection and placement right there. Now I'll do what, I'll create an empty layer and paint a contact shadow between the cat and the road. I'll paint the shadow based on the direction of the light coming on the cat. The light is coming from the right side, so I'll paint the shadows on the left side. Just fade it a little bit. So here I just quickly painted a contact shadow between the cat and road, and now you can see both the cat and road are connected. It's not very realistic for obvious reason. Like I said earlier, the lighting is different, the perspective and scale, everything is off on both the subject and the background. They do not match at all. But just with the help of a contact shadow, the image is connected. It gives you the illusion that the cat actually is there. This is the power of a contact shadow. Now I'll get more technical and practical, and I'll show you how to determine the shape, direction, darkness and smoothness of a shadow. So the first and very basic thing is to observe the scene. See whether the light is coming on both the subject and the background from the same side. For example, let's say we have a background here and a basketball. Now I'll change its position and place it right here. As you can clearly see, the light on the background is coming from the right side and the shadows are formed on the left side here. Light is coming from the right side and the shadows are on the left side. And the same thing is for the basketball. Light is coming from the right side and shadows are on the left side. So these are good assets for a composition. If I were to just invert the basketball or the background in other direction, it will instantly become a bad composition because the lighting on both objects are coming from different sides. The lighting on the background is from the right side, on the subject is from the left side, which doesn't make sense at all. The first and very basic thing is you have to make sure light is coming on both the background and the subject from the same side. I'll quickly undo this and just paint a nice little shadow under the ball, and there you go. It looks very real. Now we'll get into the very first step on how to determine the direction of a shadow. So here we have this nice road texture. There is no light source visible, so it should be dark. I'll make it dark right here. Let's say here this is footpath area. We're seeing the road from the top view. So let's say we have a street light right here in the middle of the footpath. This is how a street light normally looks. So let's say here's a street lamp and it's a top view, so we are seeing it from the top view. So here we have a street lamp, this is a footpath, and this is the road. Now I'll lit up the street lamp to make it the only light source in the scene. So here I will quickly add a nice little glow to lit up the street lamp, and street lamp being lit will also result in lighting up the road as well. So this is how a street lamp will light a road. Now we have a scene, a light source, some light and some shadows. So as I mentioned earlier, we'll place the subject according to the background. So here we have our subject basketball again. The shadow is on the bottom side here as you can see, but on the image it's on the top side. So I'll rotate the basketball to make sure the shadows on both the background and the subject are on the same side. Now I'll fix the scaling of the basketball. I'm not making it very small as a realistic size, just so you can see it very clearly. So I'll place a basketball here, then I'll copy the basketball and place a basketball here, then I'll make another copy and place it right here. Why did I make 3 copies of the basketball instead of just showing one? I'll show you the reason now. First we'll see how the light source in this case works. As you can see, we have a street lamp here and the light cast by it is in a circular direction, which means the light is going in all directions like this in a circle, just as the light comes from the sun or a candle or the normal light bulb in your home. So as I have mentioned earlier, the direction of the light on both the subject and the background should be same. Now we'll revisit our basketballs. In the first one, the light is going in this direction, so the light is also in this direction. It makes sense. On the second one, the light is going in this direction, but on the basketball the light is going from this side, so it's wrong. On the third one as well, the light is going in this direction, but the light on the basketball is coming from this direction, so it's also wrong. So let's fix them first. I'll slightly rotate the basketballs so the light on them and the light source is equal. Now we have correct positioning of the background and the subject. So now we'll get into the shadows. So as you know how shadows are formed. Shadows are formed where light can't reach. So here from the street lamp, the light is going in this direction, like a ray in a circular direction in all sides. So these are the areas where light is reaching. These are the areas where light is going. And where light can't reach is the area here, the area here, and the area here. Basically the areas behind the basketballs, because these areas are blocked by the basketballs. The basketballs here are blocking all the light to go back further. So these are the areas and directions where our shadows will be. These are the areas where our shadows will be. I'll keep these guides visible so you can see them while I paint the shadows. Right, like this. So I'll just add a multiply layer and quickly paint some shadows here. Right, like this right here, and like this right here. Now I'll turn off the guidelines here, and as you can see, this is how you determine the direction of a shadow. This is why I put 3 basketballs in this composition, to show you how the direction of a shadow on each object will change according to their position in the composition. A lot of people do this mistake. Is what they do is just grab a soft round brush and paint all around the subject shadows, which looks very ugly. This is not how shadows work. There's no way a shadow to be in front of the basketball because lighting hitting there. Light is only blocked here by the basketball, so the front of the basketball will be in completely light, and only behind the basketball where light can't reach will be the shadows. And once I erase the shadows in front of the basketball, here you can see it looks a lot better and realistic. Now I'll show you one more example on quickly determining the direction of the shadow according to the direction of the light. So this was an example where our light source is a street lamp and it's completely in view. But what if we don't have a light source in the scene? We don't have a street lamp and the light source is sun, which is not visible in the scene. So that will definitely affect the direction of the shadow. The shadows will be not going all in random like this. It will be different. Let me show you how. It's normal for you to assume that the sun is circular and it also emits light in all direction, just like the street lamp was. So the shadows should be also same because the sun is emitting light in all direction. But this is very wrong because of the scale of the sun. The sun is so large, the sun is huge, and the earth is tiny. So it definitely emits light in all direction. That's a fact. But its scale is so big that when you zoom in on the earth, you can see the light emitted here seems almost parallel. The difference like here is almost negligible. You can barely see the change in direction unless you are in a very large space and 2 objects are placed very far separate. But these are closed basketballs on a simple road. Normally the sun is so big, the light coming from the sunlight will be parallel, not going in all direction. That's not how the sunlight will work. Now you might be thinking, if that's the case, then how do I explain this, where the light is clearly coming from the sun, but the shadows are in all direction, not parallel? They are going in all direction like a ray. How do I explain this? How do I explain this? The shadows are going in all direction, not parallel, just like I said. Or even in this example, the shadows are some shadows are going in this direction, but some shadows are going in this direction. So how does these happen? So what's happening in these scenarios are not about the direction of the shadow, which I am explaining right now. I'll explain about this, about the perspective and shape and position of the shadow, where you will understand how shadows distort in different type of perspectives and what kind of sharpness and shape a shadow has to be. So hold tight, I'll explain that as well. Before that, let's get back into the scene here. We now know that the light is parallel in here because it is coming from the sunlight. Also, we don't know from which side this is coming from because the ground is completely plain. But if you zoom in, you can clearly see the light is coming from this direction because the shadows are on this direction, because the shadows are on this direction on the tiny green rooms. But we are not going to nitpick that and do it super perfectly like that. I'll just assume this light is coming from this direction, just the same direction from where the light was coming from the lamp. So I'll just assume that and we'll fix the positioning of the basketballs according to that. So all the light part of the basketball will be facing down. Now I'll rotate the basketballs so that they are facing the light source, just like this, and create a multiply layer, choose a dark color, and paint some nice shadows behind the balls. And there you have it. Now here's one more thing you might be pondering about. Since the basketball is round in shape, just say we are seeing it from a side view, not a top view, it does not only cast shadow behind the basketball, but also slightly in front. That's also according to the light source. Obviously, if the light is coming directly from the bottom, there will be no shadows right here. But normally, as the lamp you saw or the sunlight, it's usually on far top. Light is usually coming from the top. So as a circular object, even in front there is some part of the light which does not reach. For example, let's say here's a source of light and the light is coming right here. This is how it will come like a ray. So you can see there's some part here on front which gets hidden by the ball. So this is some area where shadows will be painted in front as well, and on the back, obviously back as well, this part is entirely darkened, so this part will be darkened as well. But why do we not paint shadows in front here? Because when we see it from the top view, we are seeing it from top view on a parallel, so this part is not visible to our eye. That's why I did not paint any shadows in front of the ball. So if you had any questions regarding that, I hope that solves it. So this is how you determine the direction of a shadow, by determining the direction of the light and following the light rays.